Hi, welcome to the Leukopak Lady. Today I'm discussing the importance of analyzing a donor's PBMC subpopulations and the function of those cells to help determine which donors are ideal for a developer's specific therapy. Determining whether a donor has high levels of the specific cell population that a therapy is built on can really help enhance manufacturing success. Even when collectors better standardize the number of PBMCs in a leukopak, the percentage of key lymphocyte subpopulations may still be highly variable between donors. Testing donors before qualifying them for apheresis can increase the chance that enough cells of the starting population are present in the final product, especially for therapies built on rare cell populations like T stem cell memory, gamma delta, and NK cells. The apheresis calculator that I outlined in a previous video can be especially helpful here. In addition, collectors use their donor pool more efficiently by tailoring the donors available for certain developers based on their immune cell phenotype distribution and the developer's target therapeutic population. For example, donors with high NK cells can be recruited for collections intended for a therapy built on NK cells, while donors with elevated numbers of gamma delta cells can be recruited for collections intended for a different developer. To make this work, the collector should test the donor's immune cell phenotype distribution using flow cytometry, ideally early on in their participation in the Leukopak collection program, and keep these results, along with other donor characteristics, in a database easily accessible for identifying and recruiting donors for a specific collection in the future. And it isn't really practical to test for all possible immune cell populations, but testing for the most commonly used cell types for therapeutic development can go a long way, and, if needed, help identify donors for additional testing when a developer needs additional analysis for a more rare population. But likely the most important aspect to predict a therapy's success is how the donor cells perform in assays to assess their manufacturability. These assays are typically performed by the developer at their own lab location. This is done to protect confidentiality of the test approach and the results, as well as maintain standardization and supervision over the performance of the assay. In addition, some of these assays take weeks and months to perform, so it really is more practical for developers to keep these assays in-house. Collectors help here, though, by providing donor samples or leukopaks for use in these functional tests. And if you pair this with careful and deliberate donor recruitment based on other key donor parameters important to the developer, like health history, CMV status, and elevated levels of key immune cell populations, the likelihood that the donor cells will perform successfully in the functional assays increases. And once the developer qualifies donors based on their cells' assay performance, the collectors can then reserve those donors and recruit them specifically for the developer to ensure the long-term success of their therapy. And examples of performance assays include tests for infectivity, activation, proliferation, and target killing in culture, as well as survival and function in xenograft animal models. So on the next episode, I'm going to return to the discussion on flow cytometry and whether it can be used to determine if a donor's cells will be functional. And then I'll discuss an advanced technology to employ in donor qualification that may make performance assays unnecessary.